All right. View the waiting room. Admit them all. Whoops.
I thought you forgot we had class.
Oh, I would never forget. It would be impossible. I'm just running on Italian time, so 6:30 on my watch. Okay, I'll just wait a minute just for people to filter in here. I just wanted to give an overview of sort of what this week looks like. And we will see how many people show up. How many people got the message that we switched times, I wonder. We got, yes. Okay. All right. One more person filtering in. If you guys happen to know anybody else in the class, do them a favor and let them know that we switch times, but also if they miss anything tonight, maybe to let them know. So I'm going to go ahead and start. I'm going to do my best to admit people as they show up in the lobby. Okay, a couple housekeeping things then today. So I'm just going to quickly share my screen. Okay, so you guys should be looking at the course outline here. And let me just get rid of those non-printing spaces. A little bit easier to look at. Okay, so what we got then is we're on the home stretch here. We are right here on March 22nd. So supposed to be correlation coefficient and linear regression. So what I've done is I just uploaded 5 videos to YouTube. Now don't let that scare you. I'll show it to you right now. So here's our statistics playlist that you guys always go to get the videos. I haven't posted these links to Moodle, but what I can do is maybe post, I'll copy and paste the link into the chat. But anytime, if you click on any of the videos on YouTube, it's going to bring you to this playlist and you can click on these last 5 videos. So it says week 10. And part 1, part 2, part 3, part 4, part 5. Now, it's simply just broken up into smaller chunks. So instead of just having everything all in one video, it's just 5 videos. So don't let that scare you. This week is pretty calculation heavy. These videos are actually created by someone else who's done a very good job. Some different DeMuro. So I'm Matteo DeMuro. This is created by a different DeMuro. They're very well done. And they're very focused. And in total, let's see, 9, 17, 28, 36. Yeah, it looks like about 45 minutes of viewing, approximately. So pretty in line with what we normally have. I'm going to recommend that during the class time that you view these. Now, these ones do not follow my notes. So what you're going to want to do is get a blank piece of paper and just copy out the data. They're all very small examples, pretty easy to copy down, and watch them a few times. I noticed some videos have some pretty low view counts, which just means that people aren't watching them. So that's, that's how we're delivering the course. So yeah, make sure you watch them more than once. And then you also have my own notes and then the exercises that are online. So these are like some extra examples. They're going to show you the concepts. I'm going to stop sharing here for a moment. And there's nobody in the waiting room. Okay, good. Okay, so I was going to also show you. Yeah, I was going to give you this link here. So I'll paste this in the chat. So I believe that should take you, I'm going to just double check. It should take you to the, yes. Okay. So, and I'll eventually post those on Moodle. Okay, what is next here? Okay, so right, then the actual notes themselves. Just bring those up. Just as an aside, I did post the mark sheet. I don't know. Does anybody have any questions about it? I lowered how many grades the first two midterms were. So you'll see there's a new row that says adjusted points. So basically, I should double check that it's actually where I'm pretty sure I did. But yeah, my intention is that basically everybody got a boost. So I think the second midterm I took 3 or 4 points off. So basically it's like adding 3 or 4 points to whatever score you got to on it. Same thing with the first midterm. I think I reduced it by 3 points. I left the labs sort of as is. I don't think I'm going to change them. You guys they're open book and all those things. So, but the midterms, that's what I did for now. The final exam that's coming up. So we have a flex week. So the week before the final, we don't have any new material. That's by design. So we can do some review. And as far as what it's going to cover, like, we have like 2 or 3. We basically have 3 lessons of new material. So that'll obviously be on the exam. But then also it'll go back to the beginning of the course and sort of cover a little bit of everything. It's 45% of your final grade. Traditionally, what ends up happening is if you have an 80 going into the exam, most people will walk out with essentially the same grade. So what you generally see on the exam is, you generally get what you already, you might get 5% more, 5% less, but that's generally what happens. The story, if your grade's a little lower, usually like in the 50, 60 range, then anything can happen. So you can walk out with a 60, and I've seen people with a 60 go in and get like 20% on the exam. Not trying to scare anyone. I'm just saying, like, it's a heavy course. There's a lot of material. Make sure that you're studying and be realistic about the exam. I have people asking me, if they can get 30% higher. It's like, I don't often see that happen. Not being pessimistic, just realistic. You got 3 weeks left. And if you have a lot of gaps from the beginning of the course, it's going to be hard to keep up with the new material and bring yourself up to speed. So it's not too late to really start getting at it and doing, a few hours a day. I'm just saying, like, if you're not already doing that, then consider doing it. And you can redo assignments. You don't need to do new questions constantly. You just need to keep doing the questions you have until you actually get them. Like, you're not looking at the answer key. You can recite the concepts. You begin to know the formulas by heart a little bit. You can recognize questions. Those are all good signs. Right, I just got a question. Do you have another lab? They didn't grant me a marker this term. I've always had a marker, and basically what it means is I'm struggling with, creating the content, which I normally wouldn't have to do, right? I just have to show up and teach. I'm struggling with that and doing all the grading and stuff. So I'm leaning away from doing a third lab. But what I will do is I'll try to make up and just have some extra bonus assignments and stuff like that. I'll do a bonus for this week, maybe based on confidence intervals, which is last week's material. But I won't release it until I'll send it out in an email. So Tuesday or Wednesday, and I'll leave it up for, I'll be more lenient. I'll leave it up for 3 or 4 days or something like that. So yeah, and then just a reminder, the bonuses get added on to your final grade. So if you have a final grade of 82 and you got 2% worth of bonus, then your final grade would be 82 plus 2, 84. So that's also pretty good. And yeah, I don't know if there's any questions before I quickly, yeah, the final, okay, so I got a question here. How long will the final exam be? So it's the standard final exam is usually 3 hours at BU. So that's the total time that you get to write. We write it during the class time. So it would be from 7 to 10. That I have to stick to because for scheduling, like, you might have other classes. So it's got to be from 7 p.m. to 10 p.m. And generally the exam should take you about 2 hours to write. Yeah, so probably about an hour, 50 minutes, and then you have an additional 60, 70 minutes to look it over or check out a question you might be stuck on. So I hope that answers that. Perfect. Excellent. So yeah, I have an exam review as well that I'll release. I'll release an old exam as well, so you can check out an exam from a different year. You know, when you really look at it, they're not that, you know, they're like, you know, compared to your midterm was like, you know, 5 questions and then some multiple choice and stuff. The exam isn't a whole lot longer. You know, can't quite remember. I don't want to say, but yeah, it's not a ton longer. Like it's a little bit longer, but it's kind of like another midterm, but it just summarizes the whole course. Maybe that's what I'll aim for. I know it's hard to learn. Like I have a lot of sympathy for you guys trying to learn in this manner. It's not, we can't do online like anywhere near what we can do in class. So, you know, what that looks like, whether I knock some grades off the denominator of the exam and everybody gets a little boost. Do any professors still use a curve? Does anyone know? Anyways, I don't, okay. Yeah, well, a lot of professors still use a curve, which I don't like because then it, you get a different boost depending where you are. So that I'd rather just give everybody, you know, 5 or 6 or 7% for free instead of, you know, just arbitrarily boosting some and not others so much. So, oh, what's that good? Some of you don't know what a curve is. That's a good sign. That means it's not getting used as much as it used to. I took a class where I got like the professor, the tests were too hard. So what would happen? He's like, oh, it's fine. Like, so like say the highest mark is a 60, then I take the 60 and that becomes like 130%. And then, you know, and all the other marks, you know, like kind of go up. But what happens with the curve is if you're near the top scorers, your mark explodes exponentially. If you're sort of in the bottom third, you don't get as much of a boost. So like I would get like a 60 or 70% boost sometimes, but I had a friend who like usually score like 30% and their boost wasn't 70%. They get like 20% boost or something. Anyways, I'm not going to do that. Okay. What I kind of thought we might do just really quickly, because I realize you guys haven't seen the material and you need to go look at it, is just wanted, like, all the stuff's on YouTube, and I kind of wanted to do like wanted to take the Excel lab and just show you guys sort of what this stuff looks like a little bit. So I'm gonna have to share my screen again. And the videos do a really good job of explaining everything, I think, but I'm just gonna briefly use my notes and then I'm gonna show you guys some stuff on Excel. You don't need to know the Excel stuff for this iteration of the course. Let's use these notes. So I'll share my screen in a moment. Let's see here. Okay, sharing screen very soon. Okay, so what you guys should be seeing now is sort of I just want to be able to see. There we go. Freaking Zoom. Okay. All right. Sorry about that. So you should be looking at the notes now. You can check out the filled notes for this. I recommend you watch the videos on YouTube first, which do not use these notes, but these notes would be a second pass over that you can do here. And basically what we're looking at is something called a correlation coefficient. So, you know, in the business world and indeed in lots of anything that has data, you'll have variables, right? And then you're going to have relationships between those variables. So what we're often interested in is, say you have 2 variables, you're often interested in like, how are they related? So when one goes up, does the other go up? When one goes down, does the other go down? Or is it an opposite effect where one goes up, the other goes down? So there's a number that describes what that relationship is, and that's called the correlation coefficient. So that tells us basically 2 properties. And right now we're talking about linear relationships. There's exponential relationships. In this course, we look at linear relationships. So it's as simple as it can be. It's still hard, but that's as easy as it gets. There's a couple things that we can look at. So the direction, and we talk about positive and negative. The strength of the relationship. And now this is something that is good to know. The strength is basically from 0, meaning that there is no relationship, to a 1. So anything between 0 and 1. 0 means no relationship, One means very strong relationship between those two variables. And then we also talk about from 0 to -1. So from 0 to 1 is positive. It's a positive relationship. And if we go 0 to -1, that describes a strong negative relationship. So as in like they're going down together. Regression analysis is the area of statistics that examines the observed data to relate those two variables of interest. Going back to maybe high school here, so for some of you not too long ago and for others maybe more, one of those variables is going to be dependent on the other one, which is called the independent variable. So the dependent variable we put on the y-axis, and then the independent variable always goes on the x-axis, okay? So, you know, how tall you are depends on maybe how much you eat, like throughout those growing stages of your life. So your height is dependent on, say, food consumption, perhaps. So height would go on the y-axis, food consumption would go on the x, and there you have it. So here's some pretty pictures. No particular thing, but we make these scatter plots. And here you can see, you can almost imagine like a line of best fit is sometimes what it's called. You can imagine a line going through here, sort of representing the average of these points. Okay, that would be a regression line. And we can talk, this is a positive relationship because you can see them increasing together on average. This one here is a negative relationship because you can see that as one increases, the other variable decreases. So you can imagine the regression line sort of going like this. This one here is no particular pattern, or at least no, it's not a linear pattern anyways. So they're just kind of all over the place. You could apply a linear model to it and get a line of best fit, and it might even work. But I kind of threw this in as an example of no pattern. So there you go. More definitions. I think we talked, yeah, we covered this one. We covered what a regression is. I said, so simple correlation is a linear one. Only two variables are under study. So I'll show you some stuff in Excel for that. And then you guys will have questions, the homework questions to look at. And then we also look at multiple correlation regression, where we have many variables under study. Multiple regressions are more consistent with what you see in real life. So very few things can be boiled down to like one variable or two variables. Most problems in business or otherwise are multivariate problems, as in there are usually 10, 20, 30, 40, 50 variables that interact together. You know, I don't understand. I don't want to start a controversy here, but if you look at global warming, in the news media, they often talk about one variable, which is carbon. The reality is there are many variables that go in there. So while clearly temperatures are going up, and one cause is certainly excess carbon dioxide and methane, there are actually many other variables that go in there. So the analysis you get on the news is hardly very enlightened from what I know about statistics. I often kind of watch the news and I'm like, what about this? What about that? Like, what about this paper I read where like, this is a very fun field to get into, I suppose, if you guys ever go in a data analysis direction here. So, okay, now this is where I'm gonna skip. I'm gonna let my YouTube videos do this instruction. I might do an extra video just doing these questions again, but I'm gonna bring up the formula sheet here. And I know this is all rather fast. Now on the formula sheet, so we did confidence intervals last time. And what we're looking at, and we did this formula here as well, the sample size formula. What we're looking at this week is this formula here. So correlation coefficient R. Okay, that's that number that's between 0 and 1 or 0 and -1. And there are two versions of the formula, okay? I don't know if I should just get rid of one version, but I want you to be aware that when you're looking at textbooks, sometimes for this and for many other things, you might find similar formulas or different ones. So this top one up here, that has SXY and SX and SY, and then it says with correlation coefficient R equal to this. So there's all these calculations you have to do. You got to calculate this number here, this number here, this number here, and then you calculate R by doing the ratio like this. Or you can do it all in one go with this scary looking formula, okay? I don't know, I'm used to using both. They have their ups and their downs. This first one that I'm going to show you, like you can organize it in a table really nice. I do recommend organizing your work in a table for this stuff. Same thing with this one. So it's really up to you which one you want to use. You can try all the homeworks with one of them and just stick with one. And yeah, that's all I'll say. The videos also cover this stuff here. Again, these are, so these two boxes, two different ways to do the same thing, okay? So depending on how the book gives you the data, sometimes you need this one, sometimes you need this one. I will stick to one for the final. I just can't recall which one it is at this precise moment. Okay, so this is that first one, finding the correlation coefficient. What we're gonna have is, again, there's two variables here, okay? So it'd be gonna be easier to demonstrate with the problem, which I'll do in a moment, but you have your X data and your Y data. Okay, so Xi and Yi is just each individual data point and they're paired. And I'll show you what I mean in a second. X bar, you guys know what the average is. So you can find the average of the X's, you can find the average of the Y's, and this gives you SXY. Okay, remember this means the sum starting on your first data point going to N, however many data points there are. And you're going to take every Xi, so every X, and subtract X bar, then multiply it by every Y, subtract Y bar, and you add those all up. These are very similar formulas. Notice the square root symbol here, and this is SX and SY. And what's the S mean? It's standard deviation. You're finding the standard deviation. So you're finding a grouped standard deviation here, and then a standard deviation for just X and just Y. Okay. We talked about this, so I'll skip that. Right, we should talk about this for a second. So what's a large R and what's a small r? So I said R can go from basically -1 to 1, right? 0 to 1 for positive, 0 to -1 for a negative correlation. So if you have -1, that means you have a perfect negative correlation. If you have +1, you got a perfect positive correlation. If you have -0.5, that's actually considered a moderate negative relationship. So when you're going to calculate this R value, sometimes the question asks you, like, you know, are these two variables strongly related? Are they moderately related? Is there kind of a weak correlation? And where those cutoffs are kind of depend on, you know, which philosophy you subscribe to. There isn't necessarily any industry standard. And sorry, my kid just got back, so it'll be loud for a moment. But generally anything above a 50%, so 0.5, is considered like a moderately strong relationship, okay, between those two variables. The closer it is to 1, the better, but you don't often find that. Right, and a 0 indicates no relationship at all, okay? Or I guess, yeah, no linear relationship. Maybe you're just using the wrong model. Okay, we talked about this on the formula sheet. If we're using populations, this is the notation, but we never are. We're always going to use samples, so you're always going to see this one. And here is what an example looks like. Now, there's so many calculations that I'm not going to do it now. I just have it in a table. But the example is just finding the sample correlation coefficient for this data set. And it's advertising expenditure and sales volume. So you usually have to identify what's the dependent variable and what's the independent variable. So advertising expenditure means you're spending money on ads, right? And then the corresponding sales volume. Okay, so do you think the sales volume depends on the ad revenue, or does the ad revenue depend on the sales volume? Maybe not very clear, but probably your sales is going to depend on your advertising. Right? If people aren't aware of your product, you might not sell very much. If everybody knows when you say, you know, Nike, that they sell shoes, well, when they see it in the store, they're probably going to be like, oh yeah, I saw a commercial. Our brains work literally like that. You're going to pick the thing that is familiar to you. If you're presented with 10 things and they're all shoes, and you saw one commercial in your life that was a Nike commercial, you're like, oh, I know that one. And you're much more likely to buy it. You're also more likely to buy it if it's at eye level and all these other things. Anyways, should bring my brother in as a guest speaker. This is literally marketing. He has a PhD in marketing, and that's what he does. Anyways, so here's Xi. So that would be some unit of advertising expenditure. It doesn't say. It could be, you know, $500. It'll probably be in thousands of dollars or something like that. And then here's the corresponding sales volume. So notice how, so this is the part of the formula we're trying to calculate. So you got to calculate SXY, okay? And you just set up a little table. So here's each grouped point. So 5 for X, 89 for Y, and 6 for X, and 87 for Y. And you got to do this little piece of the formula, which is right here. So it's xi minus 9.5. And if you want to try it right now, we'll zoom in a bit, right? You can try going, oh, we need to calculate x bar. Did they give us x bar somewhere? Oh yeah, x bar is literally given here in the question, my bad. So you'll notice that the x bar has been replaced with 9.5. You could calculate it yourself, right? Just go 5 plus 6 plus 7 plus 8 plus 9 all the way down. Get a total of 95, divide by the number of numbers. There's 10. That's why we get 9.5. Okay. Same thing with y bar. Here it is calculated for you, but you could calculate it yourself. Sorry, I can't really see the chat, so I don't know if anybody asked a question. If you have a question, just make sure you speak up. The question I often get is like, how big are the questions that we're going to do? Like, how big are the questions we do, right? Like, are you going to give me like 10 data points or something? And the answer is no. I probably stick to about 5 data points. Okay, so you can cut this question in half, and that's what you'd likely see. Your homework is fairly reasonable like that as well. This example question is a little long, which is why I sort of pre-filled it out for you. But I encourage you to come back to this and try calculating all these things and make sure that you do it. So download the blank notes and actually try it out. There's no hard math here, right? Like you're just subtracting numbers. You got to be organized, keep it in a table. And then to get this number here, remember, you're multiplying, right? You're multiplying these two numbers. So you're taking the negative 4.5, multiplying it by this, that gives you this number here, okay? And I promise you my numbers will be nicer than this when I give you a question, okay? So you add that all up and then you get 365.5, okay? Now the formula says take that sum, divide by n minus 1. So we divide by 9, and this is your SXY. So it's your standard deviation of the x and y variables together, okay? You also need to calculate your standard deviation of x using this formula here. So now we have this column here, but notice how you're doing the sum of each one squared. Okay, so you got to take this number and square it, and then add it to this number squared, and this number squared, and this number squared. Okay. Don't have that work. But when you do that and divide by 9 and take the square root of it all, you'll get 3.02. You just have to try.
Can you repeat this idea, please?
Can
you repeat the last idea, please?
I didn't catch that.
Can you repeat, please?
Oh, yes. Sorry. I'm sorry. I certainly can. So how far back do you want me to repeat? Like how to do this?
Yeah.
Yeah.
Because this is, I think this is scary and we're going too fast.
Yeah. Okay. Yeah. So like you're taking this 4.5 and you're squaring it, and then you're adding this one squared, and you're doing that for every single one.
Oh, okay. Got it.
Yeah. Yeah, I don't have the intermediate calculation, but got to do that all and divide by 9, then do the square root, and you should get this. Same thing with standard deviation of y. So you take this number, square it, this number, square it, add them all up. I recommend just having another column in your table where you do that, okay? And you should get this. Now, how do you find R, the sample correlation coefficient? Well, it's literally just this fraction, and remember, this is on your formula sheet. So you take SXY right here, divide it by SX times SY. So multiply those two numbers, go 40 divided by that answer, you get 0.93757. And then the question is, what does this mean for advertising expenditure and sales volume? Well, it means that when you increase one, you increase the other, but not, actually, let me rephrase. When you increase advertising expenditure, you increase the sales volume. How correlated is it? Well, it's very close to 1, so it's an incredibly strong correlation, okay? In this case, so for whatever, we don't know the context, you know, what are the ads? What are they selling? We don't know. Just this data, That's what it is for this particular product. It doesn't mean it works for everything, okay? Okay, that's a crash course because you will go view the 5 videos which break it down very nicely. Are there any questions? I want to show you on Excel as well, because then you can kind of visually see it a little bit. Okay. All right. Okay, good. Well, as far as the notes go, and you know, they keep going. Is there anything super important here? No. So again, my YouTube videos will cover how to get a simple regression model. So we did sort of one piece of it now, but you know, this will be covered in the videos. It's covered very well and in about 10 minutes, which is very nice. Yeah, we're going to show you this on Excel. Same thing as before. This page 18 here, the model assumptions, they're good to know for theory. So it's like, what are the assumptions of the model? But not something I focus on too much. Then it says, see the Excel file. That's what I'm going to show you. Okay. This here, slide 20, the hypothesis testing, we will leave for now. So we won't do it. And we might not do it at all. I might cut it for this year, but we'll leave it alone for this week. We won't do it. So I just want to see. So you can skip slides 20 and 21. Basically, the least squares point estimate is that other formula for doing the same thing, finding the regression lines. So you can kind of look at it as some extra work, but you'll see very similar setup with the table. Yeah, it's just all the calculations basically. Okay. Yes. Yeah. Okay. All right. If you watch the 5 videos on YouTube, then you will know what you need to know for this week, is what I want to assure you. And then you can try the homework for this week. So I want to quickly show you guys, and I'll zoom in here. So this is an area of math where you don't do many calculations by hand anymore. You might be dealing with data sets that have thousands of entries and stuff like that. Doing it by hand makes you understand like the actual theory that you need, and then eventually you progress to like, okay, now you're using you can use Excel for a lot of stuff, but a program like R, it's a program called R that's that a lot of people in this field use. I'm going to use Excel because R costs money, although I think, can you access it through BU? You used to be able to get it through BU for free, but I don't know if that's the case. Anyways, question, will this be on your test? The answer is no. I might do a bonus for this. So I might give you a data set with a lot of entries and you might have to use Excel. I don't know if you guys have Excel at home. You guys should have Excel through BU, right? Like Word and Excel, you can get them for free through BU.
Yep.
Okay. Yeah. You know what? I'm more likely to give you like a small question by hand with like 3 or 4 data points, but I just want to show you because it helps you understand a little bit. This is on Moodle, by the way. You can go download this Excel sheet, and if you look down at the bottom, basically the first sheet's the question. The second sheet is sort of the regression line with all the statistics. I think I'm just going to show you, don't want to freak you guys out too much. So I won't, I'll show you definitely number 1. And I have a video here where you can look at a tutorial for how to do this as well, sort of step by step. So that hopefully is handy. So, all right, what do we got here? We got home value and then upkeep expense. Okay, and it's just a bunch of data. Okay, so a bunch of XY pairs. So generally, you'd expect the upkeep expense to be related to the value of the home, right? Generally, bigger home costs more money, right? So let's see. Let's graph this stuff and see if we can come up with a regression line and see, and let's see if it's a linear line or not. So what you want to do is you're going to highlight everything if you're doing this in Excel. So you highlight all the data. Okay. Then you're going to go over up here at the top to the Insert tab. Oh, there's people in the room. Hopefully they weren't there for too long. Okay. So where was I? Right. Then you go over to Insert. Okay. And then over here in the middle, you see the Charts tab. what you're going to want to do is look for the one with all the little dots. And then if you hover over it, it's actually going to insert it for you. So we just want a scatter plot. So it's that first one there. It says scatter. And you click on it. And now you have a nice little graph of all those data points. I think if you right click, change chart type. No, it's up at the top. If you want the labels and stuff on chart design, you can click on a bunch, and eventually there should be one that has the freaking things on the side. Maybe not. Is it this one? I'll find it. I'll find it eventually. Whoops. We'll just go like this. We'll leave it basic right now. Okay. Now what? This is what Excel makes so easy. If you just right click on the chart and then go to, whoops, might have to select the data actually. Right, so select the data. So just select one of the data points. It should select them and just right click and then just go add trend line. It brings up this little dialog box over here. So you can choose what kind of trend line you want. So whether it be exponential, remember we're only doing linear. So I select linear. Almost looks like exponential could work. You need more data to really be sure if exponential was the right, but that doesn't make sense. Because exponential means at a certain point, so it looks like at about, if you imagine this continuing at like $350,000, like your house upkeep becomes like super duper high. So that probably doesn't work. So it's probably more like linear. So there it is. And now what you can do is down here, so set it to linear and then display equation on the chart and display the R squared value on the chart. And what this is, I don't know if you guys can see, I'll zoom in here. Couple things. This right here is the actual equation that'll generate a point on the graph. So X is your independent variable, which was your, let's see, what was our X? It was our home value. So you plug in your home value, multiply by this number, subtract this, and you'll have your approximate upkeep cost. Okay, so getting this formula is part of what the notes cover this week. So that's in the YouTube video. So basically, you're going to be calculating this number, and there's a bunch of formulas to do that, and then calculate this number as well. And then you plunk it together. That was that BO and B1 thing that you saw, that we briefly saw on the slides. Now this number here is R squared. Okay, so that is the, where'd my calculator go? No, I have an extra one. That's the correlation coefficient, that R number that we were looking at before, but it's the squared one. So if you do the square root of it, then you get, so if you do the square root of 0.8892, you get 0.943, okay? So that's the correlation coefficient that's telling us there's a very strong, this is very close to 1, there's a very strong association between those two variables. Excel gives it all to you. So if you can plunk your data in Excel, you can take all those big complicated tables and say goodbye, and you can get all these numbers with a couple button clicks. Isn't that nice? I really thought you guys would be cheering for joy, because what this means is that you can at least check your work. Right? Like if you can get Excel on your computer, you can check your work, right? So you can do a question, you can quickly check and see if your numbers are correct. Now I need to see the work. So some of you, hopefully no one's thinking like, oh, so I can just not learn this, plug it in Excel and get all the answers and write it down. Remember, on these questions on the test, I need to see your work. But what this means is you can check it. So you can do your table, you can have your numbers, you can plug it in Excel and see if you got, the right thing. It'll be very close. Are there any questions? I hate this. I hate not being able to see anybody. I can't gauge your reactions. In class, be able to see if people are looking confused, or people also generally throw up their hand and ask questions, and we can spitball. But does anybody have questions? All right. Good. I just imagine that you guys walk away from the computer and then your cat like jumps on your chair and is like staring at the screen while I talk or something. Nobody's actually there. Is there anybody there?
Yeah,
Oh.
there's someone.
Oh, good.
Yeah.
Excellent. Good.
Yeah.
Oh, sorry, I'm staring. My kids are looking at me. Did you go to bed? No. Nothing. I'm talking to my friends. Oh, Flouncy's in here. Yeah. You want to come get him? You guys seem pretty freaking cool, huh? Rucker. Sorry, give me a second here. He's gonna
Thank you.
want his Flouncy. I try to. Okay. Right. I'll be right back, you guys. Come on. Are you showing off? Oh. Okay, sorry about that. He likes to show off for the crowds. Okay, I think that's good for just a quick intro. I don't want to take up too much of your time, and I don't know if this has been useful at all. I thought it'd be nice to see a little bit of, like, understand what we're doing. Like when you're doing all those weird formulas, you're literally doing you're doing this. Like you're doing this stuff that Excel does. Like you're kind of the scatter plot and then getting the regression line. That's what you're doing, just to put it in context. I don't know if that helps. It would have helped me when I learned this stuff. We didn't have, I'm not that old, but I didn't see it done on a computer until like a couple of years later. So I just had to sort of, I don't know how I learned it. I really don't. Okay, it was magic. So any questions? Anything about the course I can clear up? Okay. So, okay, all right. I will try to, oh, I think I
I
heard
have a question. Can you post this recording somewhere?
Yes, I can. Yes, I will post literally as is, just raw. Yeah, I will try to do that by the end of the night. It takes quite a while to upload, but yeah, I will send out an email and let you know when it's on Moodle. Does that mean this was useful?
Um, let me be totally honest. This is scary more than it's useful. We need to see it many times.
Yeah, I just want to leave you guys with, like, I don't want to scare you guys. Like, you're not doing the Excel stuff. You can certainly double check on Excel. I'm not gonna ask you questions where you need to use Excel. I want that to be very clear. An objective of the course in the course calendar is that you learn how to do some of these things on Excel. So normally, if you're looking at the calendar, normally I would show you the Excel stuff next week. But because I actually want to focus a bit more on the calculations and stuff, we're going to skip that. I showed you very briefly now. You're not required to know how to do it or anything, okay? I'm going to try to, like, this stuff will be on the exam, okay? The questions are small. I try the homework. I'm going to try to, I'm concerned about the grades are lower this year basically than they traditionally are. So it's hard to say why, okay? I know a lot of previous years would have loved to have the videos. Some people wanted me to record the lectures and I just didn't have the capacity to do that because we were in like the big lecture hall and it's just too complicated. So yeah, I'm struggling with how I can equalize that a bit, because I realize that part of it is just it's hard to learn an entire course in this format, okay? Yeah, so I don't know. What I'm trying to say is, study hard, and I will try to focus the exam a little bit more towards previous weeks. You can expect some regression, like a regression question or something like that for sure on the exam. So I'm not saying, you need to study this stuff. It will be on the exam, but don't forget about the rest of the course because it will be on the exam. Okay, so you get a second shot at, say, the midterm 1 material and the midterm 2 material after having a few more weeks at attempting it, okay? That being said, I'm going to let you guys go. All right, I'm going to stop recording. Is it even recording? Oh, I have to stop sharing first. Okay.